Hey guys, today we are going to talk about the trench system and the ridge system, and our activity today is on the mid-ocean ridge system. So if we look at this map first before we get started, we're going to talk about mid-ocean ridges and trenches. So that's what the lecture was on today. If you look, you can see here's North America, we've got South America, we've got Eurasia, we've got Africa and Australia. So we've got a trench. Everywhere you see this line, if you look at the key, everywhere you see the line with the dots is a trench. Everywhere you see a straight line is a transform fault. And everywhere you see the two lines that are dotted like this is a ridge system. So remember, at the ridge system is where the magma is coming up out of the earth. At the trench system is where it's going back in the earth. So for the activity today, we're actually gonna look at this ridge and trench system right here. So we're gonna use this mid-ocean ridge, and we're gonna use the trench over here in your Asian Pacific Islands, and we're gonna use the trench over here on the coast of South America. So we have got what Miss Neal is going to call her model of the ocean floor that I'm about to put up so you can see it. All right, we've got 3 slits going on in my ridge system. We've got the middle. This is gonna be labeled slit B, and it's your mid-ocean ridge. Over here, we have slit A. This is our Andes mountain range. This is the coastline of South America. Over here is slit C, and these are our Pacific Islands. Or Australia. So about 40 years ago, scientists discovered that there's not only age patterns in the seafloor, there's also magnetic patterns in what comes up out of the seafloor. So it allowed another piece of this tectonic plate puzzle to fall into place. So we know that new seafloor continuously forms over millions of years. And what happens is at these mid-ocean ridges, hold on a second, Miss Neal needs to insert her magma. At these mid-ocean ridge systems, what's going on is magma is rising to the surface. We should have learned in our density lessons that cold water is more dense than hot water. Heat rises, so this magma is gonna rise. And as it rises, it reaches the cold, cold ocean water, and that causes it to cool off and set. And it keeps continuing. So in some places, this new rock is pulled apart by the plate's movements, forming 2 rock masses that move across in opposite directions. So the seafloor is spreading very slowly away from this ridge, and it results in symmetrical patterns of age on both sides of the mid-ocean ridge. So your newest rock is the rock that's gonna come up out of this ridge and form. And it's gonna split, and it's gonna split exactly evenly. But what do you know about magnets? If the 2 things are alike with magnets, they're gonna repel. So they're gonna go in opposite directions. So the magma continues to rise because it's not as dense, so it rises up, it reaches that cool water and it cools. And then the pressure builds and builds and builds and builds, and it breaks through and spreads a little bit. And then it reaches the cold water and it cools and stops. And you can see as I'm spreading this apart, it's creating this little bump here, or this ridge. It doesn't happen completely flat because it rises up. My tape's not working. It rises up and out and then cools. And then up and then out and then cools. And you can see as it's rising up and out and cooling, it's slowly spreading apart, but as these like strips of magnetic material are getting close to each other, they're pushing apart. But this can't happen forever. Remember, the globe isn't growing forever. Eventually, it's going to reach these other areas, A and C. And because it's an ocean plate, and this is a continental plate, it's gonna slide underneath. And this is where we're gonna get our trenches. So this is where our trenches come into play. So this oceanic plate slides beneath the continental plate at A and C. When it slides beneath, it's getting broken down. And as it's getting broken down, it's creating volcanic and molten earth. Remember, it's not as dense, so the things that aren't as dense are gonna rise up to the surface. So that magma is gonna rise back up to the surface, and it's gonna create mountain ranges, and it's gonna create islands. So it's hitting a continental plate here. So because it's hitting a continental plate, we see those volcanoes above the ground as mountain ranges. Over here in the Pacific Islands, though, it's hitting another oceanic plate. So when it hits it, those volcanoes aren't going to show up on land. They're going to show up as volcanic islands or chains of volcanic islands. The oldest seafloor rocks aren't as old as the Earth because this process is constantly going on. It's constantly spreading out further and further and further. It's going up and out and in. And you can see over here in the Andes mountain range, Miss Neal has reached the end. There we go. So because that is happening, the oldest rocks on Earth are only about 180 million years old, or not the oldest rocks on Earth, the oldest rocks at the bottom of the sea are only about 180 million years old because they're constantly being broken down and recycled at these trenches at A and C. So that's all the activity consists of today. So now you need to view this activity and tell me what's going on. So answer the questions. The first one wants to know what's happening here in this middle one. What's happening here at A and C. And when you're answering that, tell me what's happening. The orange paper is coming up out of the mid-ocean ridge. And then question 2 says, what feature in the ocean corresponds to that? Continue going on. If you have any questions, you can also refer to the background information. It has everything I went over in the lesson. I wish you good luck, and I hope to see your assignment soon.